Okay, so today's lesson is about casting in random numbers. All right, so the definition of casting is when you convert something of one data type into another data type. So for now, we're going to focus on primitive data type casting, but we'll talk about another type of casting later. So primitive data types, just like a review, are just data types that are built into Java. So these are like double, int, boolean, char. They're built into Java. But string is actually not a built-in data type. You can actually see this because if you type string into the jdoodle.com compiler, it actually won't turn purple, which means it's not a keyword. And that's kind of a bunch of stuff you didn't really know, but just know that primitive data types are data types that are built into Java. All right, so for now, the only types that can be casted to each other right now are integers and doubles, but it's important to know this concept. Also, you can cast to floats as well. And floats is another kind of primitive data type in Java, and it's really similar to a double, but the only difference is that doubles can hold more place values than floats. So for example, floats can hold 16, up to 16 numbers past a decimal point, but doubles can do 32 numbers past a decimal point. So yeah, that's the only difference. And you can also cast from an integer or double to a float, but there's very little use to that because double and float are basically the same thing. All right, so here's some more stuff. If you cast something to its own type, it doesn't cause an error. So let's say I want to cast 5.8, which is a double number, into a double. And even since it's already a double, I'm trying to cast it to its own data type. That actually won't cause an error. And also, when you're casting, make sure to put the type you want to cast in front of the value you're casting, not behind the value you're casting. So we'll show an example after this slide showcasing this. Let's just keep going for now. And when you're casting inside a variable, that the variable's data type matches the data type you're casting to. So what this says is that, let's say you want to convert the number, you want to cast the number 5.6 into an integer, and you want to store that value in a variable, then the variable's data type has to match the has to match the data type you're casting to. So here's an example of what it looks like. So here you want to convert the value, the double value 5.7 into an integer, and then store in the integer variable I. And so the matching that I was talking about, which is right here, is that, okay, so the data type of the variable and the data type you're casting to are the same. So int and int. I know that kind of makes sense, right? And we're just going to print it out. And so the output for this would just be 5. And you guys are like, wait, what? That's kind of weird. Shouldn't it just be 6? Well, no, actually, because when doubles are converted to integers, the decimal part is just cut off. It's just removed. It doesn't round or anything. It just gets cut off. So in this case, we have the number 5.7. The decimal 0.7 is just completely removed. We don't round or anything like that. So that's why it's 5 and not 6. It's kind of a weird thing, I guess. And this is allowed since there is a way to convert it into a double or vice versa. And this might seem kind of weird, but basically it's saying that doubles and ints can be casted to each other, both ways. But let's say you wanted to cast a double to a Boolean. You couldn't do that because, you just can't cast from Boolean to a double. So that's what this is saying. So here's another example. This time we're casting the integer value 4, we're casting it to a double, and we're going to store it in the double variable, example 1. So just like before, the data type of the variable, double, is the same as the value of the data type we're casting to, which is also double, double, double. And we're just going to print it out. So, this is not super useful, but when you convert it into a double, it just adds a decimal point because you don't know what the decimal is going to be. So it's just going to be 0.0. And the output, just be 4.0. And now here's an example of what we shouldn't do, right? We have like this little stop sign thing here. So int I equals int true. So we can't really convert the Boolean value true into an integer value. So this will just give you an error. And although, but the good part about this is that the data type of the variable and the data type you're casting to are the same. But since you can't convert true to an integer, this is not allowed. All right, so that was kind of quick. We're gonna go to random numbers now. And does anyone have any questions about casting right now? Okay, looks like there's no questions. Let's just keep going. All right, random numbers. So this is just the basic form of how to generate a random number. You put math, the M has to be capitalized, dot, random, and then parentheses. And this returns a double from 0 to 1. And as we know, doubles, there's a lot of decimal points you can do for doubles. So the numbers will get really, really precise. And this is actually very important. So when it says generates a number from 0 to 1, it does not include 1. It's very important. You'll see that pop up in our class problems and probably in your homework. So here's an example. System.out.println math.random. So this is going to print a random double number from 0 to 1. And here are 3 sample answers. As you see, the double can have extremely precise values. So that's why sometimes we want to cast these numbers into more useful numbers such as integers. And that's where casting comes into play. So, that's kind of, sort of how they link together. So here's some variations. And variations are we're just essentially manipulating the original number generated between 0 and 1 into more useful ranges, right? So it doesn't always have to be 0. It can be between like 8 and 12, 0 and 5, whatever. So here's the first one I'm going to learn. System.out.println math.random times 3. So this generates a double number from 0 to 3, but not including 3. So it kind of makes sense, right? So first you have math.random, number between 0 and 1, and then you multiply whatever number you get there by 3. So the minimum value could be 0. 0 times 3 is just 0. And the maximum value could be 2.999999999 times 3. So we'll just call it from 0 to 3, not including 3, because you can't generate 1 from math.random. And, kind of just explain this. It just generates this statement, first generates a double from 0 to 1, excluding 1, and then multiplies the double by 3. All right, so here's the second variation. System.out.println math.random plus a number. So before we were multiplying it by a number, but now we're adding it by a number. And it's pretty similar, but it generates a double from 5 to 6, excluding 6, because math.random can't generate 1 as its random number. And this is because the statement first generates a double from 0 to 1, excluding 1, and then it adds 5 to the double. So you generate a number between 0 and 1, and then you're going to add 5 to it. So the minimum value can be 0. 0 plus 5 would be 5. So the minimum value you can generate with this statement, or with this statement, is 5. And then the maximum value you can generate is 0.99999, whatever. And you multiply, and you add 5 to that as well. So the range would just be from 5 to 6, but not including 6. All right, so here's the third kind of range. And this is kind of more complex. So previously, we've just been adding something to math.random or multiplying math.random by a value. But now we're going to use both of them together. So I'll just explain this myself, I guess. So math.random generates a number from 0 to 1 and multiplies that by 5 minus 3. Okay, 5 minus 3. 5 minus 3 is 2. So it's going to generate a number between 0 and 2. And then after that, it's going to add 3 to this whole big chunk right here. So it's going to generate a random number from 3 to 5. So I didn't explain that as much. You guys get it? Just say yes or no, I guess. All right. Well, here's some sample answers. 3. Just a double number between 3 and 5. Any of that works. All right. So this is an explanation on the range. So it multiplies the double generated by math@random by 2, double from 0 to 2, excluding 2, and then it adds 3 to the range, and the range is a double from, and the range becomes a double from 3 to 5, but not including 5. All right, so here's a random integer variation. So this is where we use random numbers and we use integers so that we can generate an integer, which is more useful, or which is probably more useful than the really insanely complex, or not insanely precise, double numbers. So here's an example: system.out.println int math.random times 10. So this generates a number, a random integer from 0 to 9, including 0 and including 9. And this generates an integer instead of a double because we cast it to an int after we perform this operation. All right. So I'll just go over this real quick. Math.random generates a number between 0 and 1. And then the minimum value is 0 multiplied by 10 is still 0. And then 1 multiplied by the value 10 becomes 10. But since the number math.random can't generate the number 1, you can't generate the number 10 out of this whole thing. And then this one just remove, so just 9. All right, here's an example. System.out.println int math.random times 5 plus 3. All right, so just like PEMDAS, we have to follow whatever in the parentheses first. And here, the range is actually from 3 to 7. I'll explain why. So math.random generates a number between 0 and multiplied by 5, generates a random number between 0 and 5. And then you add 3 to that. So then it would be from 3 to 8. But then we say not including 8, the highest number it can be generated from this is 7.99999. But, and then when we convert the double number to an integer, we just completely remove the decimal. So it'd just be from 3 to 7, including 3 and 7. All right, so here are 3 sample answers that can be generated: 6, 6, and 7. All right, so here's the explanation on what happens. Okay. All right, so solve the expression inside the parentheses containing the math.random. Multiply 5 to double from 0 to 1, excluding 1, generated from math.random. And then the range from this first statement, which is actually this statement right here, will just be from 0 to 5, but not including 5. And then the second operation, which is adding 3 to it, makes it from 3 to 8. So notice this kind of interesting pattern, but every time we perform an operation on this, to find the range, after you perform the operation, you just multiply the minimum value of the previous range and the maximum value of the previous range by the operation you're performing on it. So what that does is that math.random generates a number from 0 to 1, and then multiply it by 5. So the new range would be 0 times 5, which is 0 again, and then 1 times 5, which is 5. Excluding 5, that's important. And then we add 3 to the range. So you need to add 3 to the minimum value of the previous range and the maximum value of the previous range. So 0 plus 3 is 3, and then 5 plus 3 is 8. So that's a pretty helpful pattern that might be able to help you when you do problems later on. And then finally, after you do all these fancy things, it just casts the double value get into an integer. And the final range is from 3 to 7. All right, so here are some notes. You can use doubles to generate certain ranges as well. So what this means is that so far, all of our examples have been using integer values for these operations. You can actually use doubles as well. So it could be like math.random times 5.2 plus 3.8. That would work. And these variations can all be used together to create any kind of range you want. And here's kind of just a cool little picture, I guess. I don't know why it's there. Any questions? And it can be about questions from casting or random numbers.